Welcome back. This is Mr. Hassan's Maths channel. This is question number 22 from the IGCSE Cambridge paper 2, variant 1, 0580, October, November 2023. And this question here is the last question on the paper, and we're told about this shape that ABCD is a rhombus. It is a rhombus with side length 13.6 centimeters. Angle ABC is 41 degrees. BAC is a sector of a circle with center B. So you have a sector of a circle with center B. And DAC is a sector of a circle with center D. Now, there's a few things that we can deduce from the fact that they told us it's a rhombus. One of them is that all four of these sides are the same length, right? So these two sides are identical. This is 13.6. This is 13.6. This is 13.6 centimeters. So all these lengths are the same. So we have basically, you could think of it as two identical triangles stuck together. If you join A and C, okay? And the opposite angles, of course, in a rhombus will be the same. So this is also 41 degrees, as that is up there. That's another thing. Okay, this is 41 degrees. And we can say that we have this sector, this segment here is exactly the same as this segment. They're congruent segments. So if I can find the segment of the sector, the segment BAC, if I can what I'll do is I'll call this area 1. I'll call this area 2. So I can say area 1 is equal to area 2. They're the same, identical. So if I can find area 1, which is the segment, this is a segment of the circle, okay, with center B, segment BAC, that segment there. We know to find the area of a segment of a circle, and I'm going to show my steps down here so that I'm a bit more, I don't have to keep scrolling up and down. So as I said, this is 13.6. This is, I'm looking at this segment here. Okay, this is area 1, this is area 2. Okay, so that segment, you can find the area of a segment by doing the following. You can find the area of the whole sector, which is this whole thing, which is the area of a sector is given by the angle, which is the area of a sector is, I'll write it the formula over here. The area of a sector is given by the angle over 360 times pi r squared. We're dealing with degrees, theta over 360 times pi r squared. So the area of the sector is going to be given by the angle 41 over 360, that fraction of the whole area, times pi times 13.6 squared. That's going to give me the area of the whole sector. Now the area of the segment, which is this part here, I find by finding the area of the triangle ABC, this triangle ABC, which we can find the area of a triangle by using two sides and the angle between them. Okay, so we have 41 and we have 13.6 and we have 13.6. That's a half times the area, times the two sides, which is 13.6 times 13.6, which is 13.6 squared, times the sine of the angle between them, times sine of 41. So the area of the segment is what I get when I subtract this. So the area of the segment is equal to the difference between these two, which is 41 over 360, okay, minus 41 over 360 times pi times 13.6 squared minus a half times 13.6 squared times the sine of 41. That's the area of the segment. Okay, that's the area of a segment, area of 1. Now, what we know is if I find the area of this whole triangle, and I subtract the area of the segment from it, I've got the shaded area. And then I can double it and I can find the whole area. That's one way of doing it. Or I could find the area of both these segments together, the area of this whole rhombus, and then subtract them. But I'll do it like find the area of this shaded part over here. Okay, which is going to be, you can say the area of the shaded part, in fact, we can say the total shaded area. The total shaded area, the shaded area that we require, we can do it in one step. It's going to be basically the area here doubled. It's going to be this area doubled. So I'm going to put is equal to 2 times. And now I have the area. I'm going to have the area of this triangle, okay, which is 1/2 times 13.6 squared times sine of 41 minus the area of this segment here, okay, which is the same as the area of the segment up there, which is this basically. So take away 41 over 360 times pi times 13.6 squared minus 1/2 times 13.6 squared times sine of 41. Now what I notice here, I'm going to have this minus that. So I have to add these two together, which is like finding the area of those two together. Okay, and then I'm going to multiply everything by 2. It's like I'm going to then basically, I'm going to multiply everything by 2, so that I'll end up getting the area of these two shaded parts. So when I do this, when I take away the area of the sector from the area of the triangle, when I take away the area of the segment from the area of the triangle, I'm left with this part. Doubling it will give me the area of the whole shaded region. So this gives me 2 times, and we can simplify this because you got this minus that, which is going to give you this plus that. So the 2 halves will cancel out. So you'll end up with 13.6 squared times sine of 41, okay, minus, and then you're going to have 41 over 360 times pi times 13.6 squared. So that's going to give you the total shaded area. Okay, so let's work out what that's going to be. So I've just tried to keep everything exact. So I have 2 times 13.6 squared times sine of 41 minus 41 over 360 times pi times 13.6 squared. Okay, and let's see, have I got all my brackets closed here? I have to close a big bracket, I think, at the end. Yep, I've got one more bracket to close at the end, so it won't get syntax error. So that gives me 110.334. 110.334 goes on, so we have to round to 3SF, so 110 centimeters squared, and there's the answer. So we found the area of the segment, we found the area of the triangle, we subtracted the area of the segment from the area of the triangle, and we doubled the answer. So this is the area of the segment here, this part, the area of that shaded segment, that's the area of the sector minus the area of the triangle. And then we took away that from the area of the triangle, leaving us with this, and we doubled it to find those two shaded parts together. And there's the answer to that question. It's a bit of a tough one, actually, and that's probably why it's the last question on the paper, in case you don't want to get bogged down with a question like this at the beginning. So never start the paper with the last question, because normally the last question is the one that's the most challenging, and you want to leave that till the end so that it doesn't affect you with the other questions that you might do. You won't just get bogged down with it and lose time. Right, so there's question number 22. Other questions from this particular paper can be found in the playlist that will appear in this region here at the end of the video. Other questions from this topic of, I guess it's got to do with general shapes as well as circles and segments. So I'll put 2 playlists there, and you can subscribe to the channel by clicking on this link. Thank you for watching, and see you soon.